Uh, Hello, my name is T. Kaushik Reddy from CSCB section, and my roll number is 22951A0570. And my Techtalk topic for computer organization and architecture subject is a unique microprocessor instruction set. So basically, first, let's get to the introduction. Let's first learn what is an instruction set. An instruction set is a group of commands for a central processing unit, CPU, in machine language. The term can refer to all possible instructions for CPU or a subset of instructions. To enhance its performance in certain situations, all CPUs have instruction sets that enable commands directing the CPU to switch the relevant transistors. The instructions tell the CPU to perform tasks. Some instructions are simple read, write, and move commands that direct the data to different hardware elements. Next, the instructions are made up of a specific number of bits. For instance, the CPU instructions might be 8 bits, where the first 4 bits make up the operation code that tells the computer what to do. The next 4 bits are the operand, which tells the computer the data that should be used. The length of an instruction set can vary from as few as 4 bits to many hundreds. Different instructions in some instruction set architectures, ISAs, have different lengths. Other ISAs have fixed length instructions. What are some types of instruction sets? So there are different types or some types of instruction sets. And the first one is complex instruction set computer, CISC. Processors have an additional microcode or microprogramming layer where instructions act as small programs. Programmable instructions are stored in fast memory and can be updated. More instructions are included in CISC instruction sets than in other types instruction sets. A single instruction can initiate multiple actions by the computer, such as single command launching, multiple memory access load, and store instructions. Next, another one is reduced instructions at computer, RISC. Architecture has had wired control. It does not require any microcode, but has a greater base instruction set. RISC also use smaller and a compact instruction set with a fixed instruction format. RISC produced a designed to process faster and more efficiently. Enhancement instruction sets, another one is there is these instruction types are more familiar because they are often used in marketing cups, CPUs. Examples of this go back to the 166 megahertz Intel Pentium with multimedia extensions, MMX technologies. It was introduced in 1996 and marked with enhanced Intel CPU multimedia performance. MMX refers to the extended instruction set. Why are instruction sets important? The ISA is a fundamental for building fast, efficient computers that optimize memory and processing resources. It specifies the following supported capabilities: instructions, data types, processor registers, main memory, hardware, and input-output model addressing modes. Instruction sets work with other important parts of a computer, such as compilers and interpreters. Those components translate high-level programming code into machine code that the processor can understand. Think of ISA as a programmer's gateway into the inner workings of a computer. It is essential when working with application development, assembly language, and compilers. It sets the rules for the hardware and software interface, defines what the CPU does, and ensure compatibility. How are instruction set commands used? First, data handling and memory management. Memory management. Instruction set commands are used when setting a register to a specific value, copying data from memory to a registers or vice versa, and reading or writing data. Next, arithmetic and logic operations and activities. These commands include add, subtract, multiply, divide, and compare, which examines values in the two registers to see if one is registered or less than the other. Control flow activities. One example is branch, which instructs the system to go on another location and executes commands there. Another is jump, while moves to specific memory location or address. So what is instruction set in 8085 microprocessor? A binary command that is used to perform a function in the microprocessor over uh, provided data is known as instruction. A set of instructions is known as an instruction set. Data decides the microprocessor function. Every instruction includes two parts like OP code and the operand, or you can say opcode or the operand. Operand, where OP code is usually to specify the function to be executed, and the operand gives the data that will be function on. Next, classification of instruction set of 8085 memory. Next, 80 instruction set of 8085 is divided into data transfer instruction, logical instruction, control instruction, and arithmetic instruction and branching instruction. Next, ALU, the status is where it's a basic rough diagram for the instruction set. ALU, shifter, status register, adder, temporary register, and the accumulator is used, and the internal CPU bus. So we know that there are different types of bus, like additional bus, control bus, address bus, and etc. So this diagram, INTA, INTR, RST, this interrupt control, serial input output control, 8-bit internal data bus, as we learned in the previous or the last previous slide. And then the accumulator, temperature, flip-flops, instruction registers, instruction decoder and the machine cycle encoding, instruction decoder and the machine cycle encoding, and the stack pointer, stack or the stack pointer, and program counter, increment or decrement addresses each. Then the address buffer, another one which has range, like the first one has the A15 to 8, another one 87 to 80 not, etc. So data transfer instruction. Instruction that is used to transfer the data from one register to another is known as a data transfer instruction. So the data can be done from source to destination without changing the source contents. Data transfer mainly occurs from one register to another register, from memory location to another memory location, or from one memory location register to memory. And between input output device and accumulator. Following are the list of data transfer instruction. Instruction to transfer a word. MOV used to copy the byte or a word from the provided source to the provided destination. PP, or you can say P push, used to put a word at the top of the stack. Next, pop used to get a word from the top of the stack to the provided location. Push A, or used to put all the registers in stack A. Pop A used to get words from stack to all registers. XCHG used to extend the data from two locations. XL80 used to translate a byte in A1 using a table in the memory. Then instructions for input and output of port transfer. In used to read a byte or a word from the provider port to the accumulator. Out used to send out a byte or word from the accumulator to the provided port. Instructions to transfer the address. LEA used to load the address of operand into the provided register. Next, LES used to load DS register and other provided register from the memory. Next, LES used to load ES register and other provided register from the memory. Next, instructions to transfer flag registers. LHF used to load AH with the low byte of the flag register. SAHF used to store AH register to low byte of the flag register. Next, push F used to copy the flag register at the top of the stack. Pop F used to copy a word at the top of the stack to the flag register. Arithmetic instructions. These instructions are used to perform arithmetic operations like addition, subtraction, multiplication, division, etc. For following is a list of instructions on this group. ADD used to add the provided byte or word to a word. ADC used to add with carry. INC used to increment the provided byte word by one. The AAA or against AAA used to adjust ASCII after addition. DA used to adjust the decimal after the addition or subtraction operation. Instructions to perform subtraction. So these are the basic instructions for the performing a arithmetic operation like a subtraction: SUB, SPB, DEC, NPG, CMP, AAS, and EAS. No need of deep. We know the basic meaning of the subtraction, so you can do on the depending. The instructions to perform multiplication. These are the instructions for performing multiplication. That is MUL, IMUL, AAM. And instructions to perform division: DIV, IDIV, AAD, CBW, CWD. So instructions to perform logical operation. And NOT used to invert each bit of a byte or word. and used for adding each bit in a byte or word with the corresponding bit in the another byte or word, or used to multiply each bit in a byte or word with the corresponding bit in another byte or word. So are used to perform exclusive or operation over which bit in a byte or word with the corresponding bit in another byte or word. As used to add operands to update flags without affecting operands. Next, iteration control instructions. These instructions are used to execute the given instructions for a number of times. Following in the is the list of instructions on this group loop. Used to loop a group of instructions until the condition satisfies. Next, loop any or loop nz used to loop a group of constructions till it satisfies. Next, these instructions are used to transfer or branch the instruction during an execution. It includes the following instructions. Instructions to transfer the instruction during an execution without any condition. Call, RET, and JMP. JMP is nothing but jump, and RET is nothing but return. Used to jump to provider address to proceed the next instruction or the execution. Next, what is call? The call, it is used to call a procedure and save their return address to the stack. And RET, as you know, return used to return from the procedure to the program. So these are the instructions used to transfer or branch the instructions during an execution. It includes the following instructions like call, return, jump, and these are the iteration control instructions: loop, loop E or loop Z, loop NE, loop NZ, and JCX. Loop used to loop a group of instructions until the group condition satisfies. That is CX is equal to 0. And for loopy or loop set, used to loop a group of instructions till it satisfies. It satisfies. That is the condition is nothing but ZF is equal to 1 and CX is equal to 0. Next, loop NE or loop NZ used to loop a group of instructions till it satisfies. ZF is equal to 0 and CX is equal to 0. JCX is used to jump to the provided address if CX is equal to 0. So for all different instruction control, iteration in control instruction have different condition in them. So the loop has CX is equal to 0, loop or loopy or loop Z has CX is equal to 0 and ZF is equal to 1, and loop NE or loop NZ has ZF is equal to 0, CX is equal to 0. And JCX has a condition of CX is equal to 0. These are the instructions for the transfer or the branch of instruction during an execution on the it includes like call, return, and jump. We already know that call, as I already said, call used to call procedure saving the return address to the stack, and RET is return used to return from the procedure to the main programming. Jump used to jump to the provided address to proceed the next instruction. So thank you, everyone. This is my topic for AAT Tech Talk of COA, Computer Organization and Architecture. Thank you.